I was looking around about scikit-learn regression prediction examples, but I just couldn't find the one that I really wanted it. So I just decided to make my own based off of some of the examples that I've seen online. And here we go. So today I'm going to talk about the scikit-learn regression prediction on a U.S. health insurance data set. So I'm just going to go along with it. So in the beginning, I import all the necessary libraries, especially the scikit-learn, starting from the pre-processing, encoders, transformer, and also I import polynomial and linear regression to do a polynomial regression, and also some of the metric library to review the result. And also we use a make pipeline in the scikit-learn to create a pipeline including the feature, the encoding and transforming, and then doing the training in a pipeline. So the data set, I got it from the Kaggle, as insurance.csv. And first, we do EDA, simple EDA, but I got this EDA in some of the notebook that I saw on the Kaggle. But I was trying to find which notebook that was, but I couldn't pick one. But I was going through this notebook, and then I was able to get this EDA part. And on here, if you see the data set, the insurance.csv data set has such features as age, gender, BMI, children, smoker or not, and which region and how much they paid for a year. And in here, we can see that we are trying to create basically a best fit for all these features when they're plotted against charges. So we're trying to create a best model that aligns with it. So if we such as give a certain information, such as age is 19, female, BMI 27, children or not, smoker or not, and which region, this person may pay about $16,000 for that year. So we're trying to do that, and in the initial stage, we do a library encoding first for pre-processing. On the encoding process, if you see it, we use a one-hot encoder. One-hot encoder basically for categorical but string data, we come up with a one-hot encoding basically. So if you see the data, if it's this guy or this person is from region southwest, and then it marks the southwest as one. So that's what this part of the transforming and one-hot encoding is doing. And after doing that, also the EDA process that I've seen that just overview, look over the gender per age groups, and to see that the data set is fairly distributed among the age groups. And thereafter, this one is I kind of edited my own. I wanted to look at the correlation between each features to the charges. And one thing that I saw is that age and the smoker or not was the well, BMI too. BMI. All those three are the best features that we can use, but for better visuality perspective of reviewing our data set and our model, I decided to just pick top two, so we can practice somewhat multi-feature based regression, and also we can review that on a graph. So we're gonna pick age and the smoker or not as the factor for predicting the charges of the our model. So if you look at it, as I said, I selected age, smoker or not, and the answer, which is the charges, as our data frame, pandas data frame, selected training data or train test data. Okay, so during the training process, what we do is I select key features of the age, smoker or not, as the input feature for training, and for prediction column, I use charges. So for simple polynomial regression, we have this function where we make a pipeline to do a polynomial feature on that degree, So default is currently set as 2, and then run linear regression after doing the polynomial features. So on this function or on this part of the notebook, I wanted to review how the depending on the degree, polynomial regression depending on degree, so first degree, second degree, third degree, and how our the trained model will perform depending on the number of the degree that we specify for our polynomial function. So if I see the review of the view the result of it, it does somewhat good job in following the majority of the data set for trained data. So if you see it, see this graph is that I kind of flipped mirror image this. So if you see a smoker is 0 in here, smoker 0 is on this side. So I kind of wanted to see the other side of the hidden side of the graph, and that's how we see it. And then it does follow, but it's not like wavy or it's not too varianted from degree to degree. So maybe we can just use this model as polynomial regression and then fit it, and polynomial function was as we defined up here. So in a pipeline, polynomial features and linear regression on it. But so I just wanted to see if this is really good enough or not. So if we see the graph over how the training goes over the degree. So I increased the degree over time from 0 to 10 degree. But after first or second degree, it seems there wasn't much of a change. So maybe we can just use a degree over 3 for our polynomial regression training. But maybe our the polynomial regression function, maybe it's not good enough. So I just wanted to kind of give it another try with the reach, with the default parameters with the reach, and it showed a similar behavior. So in here, I was kind of thinking maybe we can stop here, but I decided to give another go with the SVR, so SVM regression. So in here, I import the SVM regression in here, and I did a somewhat premature yet a manual grid search along all the features on the along all the parameters of the SVR. So in SVR, we have parameters like our kernel types, degrees, coefficient 0, and etc. that we can configure. And if you see it, depending on which kernel you use, there's parameters that actually changes your model. So back to the grid search cross-validation in a way. I start with searching for the kernel. So on SVR kernel, I start with the poly, RBF, sigmoid, linear, and etc. And then try to see which one performs best. And I can see that polynomial does better for mean absolute error test. And so from here, here on, I decided to select the polynomial kernel. With the polynomial kernel, and I was looking through the polynomial kernel, there's degree also affects the performance of the model. So with the polynomial selected, now I look into the degree parameter. So on degree, I give a variation of from 0 through 15, and when I run the classifier fitting and then do a prediction on the test data, I was able to see that maybe around 11 is okay. So maybe if I go further more degree, maybe it will perform better. But as of right now, this seemed the local minimum point where I can say it's good enough for now. After doing that, down on the list, another polynomial or poly letter that I saw was at the coefficient 0. So now here I am trying to come up with a good coefficient 0 or coefficient 0 parameter. So coefficient 0, I go through also starting from the 0 through. I actually wanted to go up to like 15 or 20, but it took some time. So I just stopped at 6. But if we see it along the way, about coefficient 5, coefficient 0 at 5 was good enough point of stopping it. So so now our final parameter boils down to SVR, SVM, so SVM, SVR. with a poly and degree as 11 and coefficient 0 as 5. So from there, we create our model and then I run the train. So this data set, I actually use it for validation as well. We will see toward the end of this notebook file. And if we review our data, so for say, if we review our trained data on the X, so that's a little bit, I should have used the different data, like such as temp Y, or I'm sorry, the predict X test. But here, I specified all the data that we use for our training, and then I reviewed how it performs in our graph. And then I can see that it's about following, and it's a bit more wavier than just a straight line here, where it was with a poly feature. Okay, so with that, I was thinking, okay, and even though even we had a bit of a validation with the mean absolute error throughout our grid search, and on here I used another validation process through metrics. So if you see it, I created 2 different predictions on a trained data to the trained result, and then test data, and then create a test result. And if we see it on here, as we see on the plotting, I'm actually using the train as train and test as test on our data set over Y test. So I'm trying to tell you is that it's not similar, it shouldn't be similar as this, or not using the whole data set. So in here, I plotted again against the trained data. So this is a known data set for the model, and this is how they perform. So once again here, I flip the mirror side of it. So if you see the smoker E, start from the 1 here, start from 0 here. So it's the hidden side, and we can see that it's about following, and it's better than just a simple poly feature linear regression. The SVR is giving about wavy and similar to the trained data output. And as for the test data too, so this is an unseen data set for our SVR, and it's doing about following the data points for prediction points. That blue points are the actual, and then yellow is predicted. So knowing that, we go through our another round of the MSE and RMSE and then MAE on our train, and then same thing for the test, and then we can kind of expect that for unseen data as a MAE as a I think it's in dollars, so $3,500 each difference then for as a error, mean absolute error. That's what we can expect. And the bottom part is maybe this is how we can use it for serving the model as a service. And per se, age of 33 and a smoker, maybe will the estimated cost will be this. So that's it. And currently the notebook will be also uploaded to my GitHub, and I'm gonna put my link on the description section of the video. Thank you for watching.